Hey everybody, this is Larry. This is day 8 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. And we also have a weekly premium problem video probably coming up next. Maybe. So definitely wait out for that. I say maybe, I mean, we'll get to it eventually, but it's because right now we have about 40 minutes until the contest. So 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 we'll see. Today I woke up way early to do a Central Park one. I don't know. I don't know. Let me know in the comments if I give too many updates on these things, because I don't know. Some people keep on asking me, and I don't know if it's like a good use of these video times. But it's also you can fast forward, so it's not usually too much of a big deal. But let me know in the comments. Also, two things, right? Two quick questions slash updates. One is, speed chess. Anyone watching speed chess? And well, I wanted to say spoiler alert, but I won't spoil it. But let me know in the comments who you think is gonna win and who you were rooting for or rooting for. The other one is, I don't know if y'all know. Actually, I guess I don't have it behind me right now, but I used to be a big Dota fan. I went to which one did I go to? I think I went to TI4 or TI5. I don't remember. Huh, maybe both. I went to Seattle back in the day, but that was a long time ago, of course. And if you watch Dota, then maybe you know what that means. But it's just yeah, and the TI is currently happening, and I don't watch it every year these days just because I've been traveling. But this year I happen to be not traveling and also resting a lot from all my running, so I've been watching a lot of TI. So let me know in the comments if you are rooting for any teams. This year I'm rooting for Extreme Gaming and well, Nouns, just because NA Dota, right? Anyway, sorry for the long intro, and you might not even understand half of the things that I was talking about. But let me know in the comments who you're rooting for. Maybe I'll ask again tomorrow or something. All right. Anyway, we have about half an hour to finish this problem before I have to jump onto the contest. So let's take a look. Today we have 725 split linked list in parts. Alright, given the head of a singly linked list and integer k, split the linked list into k consecutive linked list parts. The length of each part should be as equal as possible. Differ by 1. The parts should be in order of occurrence with the parts have. Okay, so basically if you have leftovers, you want the earlier parts to have it, right? Okay, so if k is equal to 5, we have a list of new heads or whatever you want to call them, right? Okay, so the idea for this one, I think the two things, right? One is, one is of course getting the size of the linked list. I'm just trying to figure out if I could do that in one, like the entire problem in one pass. Is there like a follow up? No, I don't think so. That you could do in one pass. At least, like, I mean, I guess you can. You can, maybe. But not in an easy way, I don't think. Honestly. But maybe I'm wrong about this, right? Like there's some, like every time you move, like, you jiggled, like, I don't know, you do, like, some kind of shifting thing, maybe? But I'm not convinced. And also, even if it's true, it's very complicated. So, okay, so well, we need to break this down into a couple of parts. One is to get the length of the linked list. That's the easier part, or at least like that's a part that you have to be able to do, obviously, right? So okay, so after you get the list, other than that, it's just about getting the heads of the new linked list, and also removing the connections to the head on the previous tails of these, right? So okay, so that's basically the ideas for now. Yeah, and then we can just put them apart. Let's say maybe n is equal to get length of head, right? And we have a helper function. We for this problem we'll only do it once, right? Let's say this is head, right? So current is equal to head. Count is equal to let's just say 0, and then now we have current is equal to list node, a -1 head, right? So and we don't need the new head again. Let's just, I'm trying to be too clever to see if I'm making new optimizations, but let's just say we have new head is equal to list node, -1 head. So someone asked me this in the past and in the comments. The definition is here, right? When you don't have any parameter, it just defaults it to 0 and none. But here, this is the parameter, so you could initialize it with the value and the next node. So this is what I do, right? So okay, so yeah, so in this case, then we don't have to. We get the link from new head, right? We assume that there is going to be a new thing, right? So while current.next is not none, current is equal to current.next, and count increment by 1. And then we just return count, right? So you should be able to get this one pretty quickly for any reasonable interview. That's just like traversing a linked list. It is a very basic thing that you just need to be able to do, right? Okay, so then now we have 2 things we want to do. And I'm going to write, I know that there's a mod there for those of you who know Python stuff. Why is my keyboard a little bit dirty? Sorry, that's why I'm like just getting a little bit distracted. I don't know. I think maybe I spilled something on this at some point. But anyway, yeah, so I know there's mod there, but you can write it out, right? So here we want to say we want k loops, so k linked list. So maybe we have answer, but even then we have like, okay, so then per length, right? Meaning per, or length per, maybe that's a little bit more precise. Length per is equal to k divided by, or the other way around, sorry, n divided by k, right? And I like my single constants to be like a capital. But yeah, and then now we have leftovers, right? Of course, because if n mod k is equal to 0, we mean that it's perfectly k divides into n perfectly, then everyone has the same. But if you have one left over, then the first one is bigger, and etc., right? So maybe I write something like leftover is equal to n mod k, because this is just the number of leftovers that we have to define in the beginning. And then now we have answer of this, and then now we do another traversal where we just care about yeah, right? So yeah, so keeping in mind that we have k of these, all we have to do is do for I in range of k, right? Maybe, oops, current is equal to new head. Okay, so then now we go for each one we want to traverse length per time, right? So, well, first of all, append the answer for because we want to get the head of it, it's going to be current.next, and then after that we want to traverse length per time, and if it's a left, yeah, let's traverse left per time first for current is equal to current.next, and then yeah, and then now if I is greater than, or sorry, this is a less than. I said the thing wrong, but the code was right. Then now we want current is equal to current.next, right? So that's good-ish. It's not quite done yet because, wait, are we returning the values, or, oh no, let's know. Okay, we're not done yet because we populated the heads, but we didn't chop off the tails, right? So it's gonna. But I just want to make sure that we just looking at the off by ones and stuff like this quickly. So that's why I want it. I know that this is going to be wrong, yeah, because we didn't chop off, 1 and 2 and 3, for example. But we just wanted to see whether the heads are matching up correctly. And for this one is 1, 2, 3. For this one is 1, 5, 8. So we're pretty good. We just have to kind of set this up a little bit better. The thing is that removing is always a little bit tricky, right? Because we always want to we always want the previous node to remove, like if you're at this node, you want the previous node to remove your link to here, right? So removal is always a little bit tricky, and you always have to think a little bit ahead of time. I didn't this time, and I kind of knew. I mean, I knew I was going to have to do it, but I was hoping that it would come up a little bit. Yeah, but it's not. Yeah, but the thing is that we're appending the next, so all we have to do is after we append the next, all we have to do is in theory current. Well, afterwards maybe current is equal to current, or current dot next is equal to none. But of course, we do need to iterate all of it. So actually, what we want to do is we want to say maybe temp is equal to current dot next. Oh, sorry, current, right? Yeah, and then maybe temp dot next is equal to none after all the things are, after we finish iterating, right? So this should be good. Maybe the naming variables a little bit, but yeah, maybe like previous tail or something. Maybe that's slightly better. I don't know. Yeah, let's take a look. Let's play. I mean, this is an easy thing to kind of play around with a few more things. I think one is a weird edge case. I think maybe that's it, and maybe like a big number bigger than a node. So we'll give it a spin, right? So this looks good. This looks good, so it gives me enough confidence to YOLO submit. And yeah, pretty straightforward, I think, in general. I think the two components, like I said, that you have to understand quite a bit. One is, of course, linked list. I mean, this is a linked list form. You have to know linked list. And I don't think, hopefully I'm not saying anything shocking. But the other is just this calculation of this leftover thing, which is kind of like a little bit hidden in the problem. I mean, it's not the main focus, or like it's not, they don't display it as a main focus, but it is obviously something that you have to think about. It's a critical part of the problem. You know, and yeah, and this kind of math comes up relatively often. Maybe not in this like tie breaking, they tell you what to do kind of way, but it's just, you know, like if you have to split something evenly or as evenly as possible, then it's always, or maybe not always, nothing is always, but very often it's something similar to this with some ideas. So definitely think about that. But yeah, so what's the complexity here, right? Well, this is linear with one pass. This is one more pass, right? And that's it, right? So two passes. Pretty straightforward, pretty clean, I think, mostly. Yeah, that's all I mostly have for this one. Let's take a look. What did Larry do in the past? This code is much longer for whatever reason. Maybe it's not. 52 lines, 38 lines of current Larry is slightly cleaner. But what is this? This is such weird code because I have this node thing and then I just don't use it. So I don't know. There are a lot of weird things going on in this one, and I did use diffmod this one. I did. This is I guess possibly a cool one-liner. Oh, I made new things instead of which maybe is fair. I don't know. I made new notes instead of whatever. I don't know. Oh yeah, that's what I was thinking about doing this one too. Is that yeah, all this is kind of awkward. I don't know what to say. Yeah, I don't know. I don't know what to say. So the past Larry failed this time. Oh, not this one. This one is more like what I don't know. I don't know why I keep on doing the same thing. Like I did the same thing twice, 2 years apart, but not this year. Haha. But I almost did though. This does actually reference it, even though maybe you could say that it doesn't need to. But yeah, I did it twice where the input node doesn't do anything. And here I created the sentinel here, and then yeah, I mean, I guess this is mostly the right idea. I'm curious how this works. Oh, I guess this is just 0. No, I was just thinking about like how, like I specifically handled the nuns in the past. But here I didn't have to. That's why I was like, But I guess in those cases this would be 0, and so this would just keep on appending none because current.next should be none. All right. Well, I mean that's a little bit. That's why I'm a little bit more precise. I mean, like as you can see, still room for improvement from time to time. That's all I have for this one. Let me know what you think. Thanks for watching. Like I said, linear time. I don't know how you want to count that as space. I guess linear space-ish. Like in theory, maybe you should create new nodes. I don't know. Yeah. Either way, either O of n or O of k space. It's about how you want to define it. That's all I have for this one, though. That's all I have for today. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.